for your time and for this opportunity to share this work and to just connect. So let's. What I intend to share with you today is just what augmentation means in the context of linguistic resources, some tools that we use on this endeavor, and some about the current results actually. So in a nutshell, like we know the importance of this kind of augmentation is that textual data is multi-domain, so we need a lot of data as much as we can actually, and it's just pervasive. It pervades all aspects of human interactions basically, in a way or in another. And sadly, most of the times it's unstructured, and since it's unstructured, it's really hard to do knowledge-based completion, reasoning, and actual knowledge representation from that. So when we have structured data, it's a valuable resource. And a way to start structuring text is just to have syntactic representation of the text, such as passive speech tags, dependency trees where we take the grammatical relationship between the words, and the constituency trees where we take the relationship among the words using a grammar-free parser. So, but it's still not meaning, and nowadays we have some semantic representations that try to go straight from a text and to a graph structure or another structure representing the meaning of the text. So so we can like rely on statistical methods that thrive on larger number of examples, as I said, and since we have limited data, one question that rises is that how can we enlarge these data sets that we already have, and what would be the easiest way to do that? Well, one way to do that is to just make a little change to the current annotations so it still makes sense and is still valid, and use that to create new annotations. And well, after we do that, we actually have to evaluate if it helps anyway. So we basically we take those sentence representations and try to combine them to create new annotations using different notions of equivalency, and I will talk about this later. And after that, we just evaluate if our augmentation made some improvement. So, well, the spoiler is that it improved. Otherwise, I wouldn't be presenting this particular method. But in order to make this work, we need some concepts, like the concept of the task at hand. Like we do augmentations for a specific linguistic resource, and this linguistic resource is, besides other things, useful for a task. And a task that we are going to use to evaluate our annotations is the Semantic Role Labelling. Well, basically, you have a sentence and you just have to highlight parts of this sentence with some semantic roles. And like here, we have content and paradigm. And in this sentence, and well, a resource that has this kind of annotation is the FrameNet Project, and it's actually a network of frames, and we can think about frames as a representation of an abstract concept. So here we have the concept of creation of physical artwork. So why we have this concept? A concept has a definition, some examples, and some frame elements that are the semantic roles that part of the sentence can have that link to this concept. So if I take this example here, supposedly the artist drew the picture from memory. This drew here links to the great physical artwork concept, and the artist is actually the creator. The artist has the semantic role creator as his main property. So oops, let's go on. And it's a network of frames, so we have several frames, and they are connected by a few important relationships like inheritance, use of, and some others. But and some others that we see later. And okay, so when we do frame semantic parsing, that is like the evolution, a little bit more complex problem than just semantic parsing. We have to do type identification. That is the little part of the word, like of the sentence, like this drill here, that allows us to connect this sentence to the correct frame. We and once we find this word, we have to attribute this to the correct frame. So it's frame identification. And the cherry on top of that is argument identification, where we find tokens that correspond to those frame elements. So once we find Drew, we know that Drew corresponds to create physical artwork. We can look for the frame elements, the semantic roles, to find if there is any semantic role here in this sentence. So in order to do that, we need some representation of the sentence, and one of such representations is the syntax representations. Here I'm showing you a dependency tree that is a kind of syntax parser. So we have the sentence here: they were generating grenades for export. We know that generating is a verb. Were is also a verb connected to generating. It's an auxiliary verb. Then we have this subject noun, they, that is a pronoun, and so on. Okay, so there's also the semantic representations that we can explore, and here I'm using this tool called Boxer, and we can pass the sentence trying to use it's a different set of labels, basically, of predicate, but and it's more general than just the grammar, it's actually it's more specific and covers more meaning than if we go to the grammar structure of the sentence. So if we pass this sentence here, Alice and Bob were arrested yesterday in the beach. Well, we know that Bob is a personal name, Alice is a personal name. There is a time relationship here, and it's related with yesterday. The team is arrested, so the main point of this sentence is the arrest event, and both Bob and Alice were arrested. So it's a more detailed description of the sentence. And lastly, it's not so much parser or a syntax parser. I think I shouldn't have put this slide here, but We also use Open Sesame. It's from semantic parser but we use it for comparison. We use Open Sesame to evaluate if our augmentation method is working correctly. And I will talk more about that in the experiment sections. So there's a lot of different ways to represent sentences, both syntactically, lexically, and semantically. But I'm just highlighting those few works that are really related to Boxer and the dependencies trees that we used. So our method is pretty simple actually. We have the problem that we want to do semantic role labeling, and we need to augment our pool of examples. So we take the relationship among those frames and use them to migrate some annotations from one frame to another. This way we can keep the sentence, but reuse the sentence in other frames that might be really related to that sentence. Like almost like if the human just missed to annotate the sentence with a correct frame because there are lots of frames. So one example of that would be if we have this sentence right here, like we have found ways for people with disabilities to enter the workforce. This is an example of intentionally creation, where we are creating new ways for people to enter the workforce. And this this is this is related to create physical artwork. Actually, create physical artwork is a subframe of intentionally create. Oops, I think I messed those slides. But here would be an example that I actually cannot do the augmentation here. But okay, let's move. So here we have an example that we can do the augmentation. Like here we cannot do the augmentation because we cannot say that this sentence can be represented as create physical artwork, because, well, ways of people joining the workforce is, I believe, not considered physical artwork. So at least it's not a painting or anything like that. But one way to oops, okay, it's this is not the example that it should be, but the point is that we can, when we have this relationship, when we can do this transfer is when we have a representation of the when we have a matching of the subgraphs that match the representations of the sentences. So in this particular sentence here, that they were generating grenades for export. We can do this transfer from intentional create to create physical artwork, because they share the same basic structure. So I can go here. Most of us know where we took a photo, and say that took a photo is actually an act of intentional creation. So I hope it's not too confusing, but I will know later with your questions. So in order to build those graphs and find equivalency, we can use just lexical representations. That would be the boring one, where we just take the semantic roles and compare their names directly. It's a way of equivalency, or we can use syntactic equivalency where we create a syntactic representation of the sentence and compare the substructures to see if we can transfer one semantic role from one frame to another. And basically we can do the same thing with semantic representations, that when we just try to find substructures in the semantic graph that maps to the semantic representation of in the other frame elements, in the other frame, sorry, and then transfer the frame elements that consists of the annotation. And well, we run our experiments in FrameNet release 1.5. Though that is not a lot of document, but it was a lot of work of this team to put these annotations together. And well, it contains 8,019 frames, and roughly 70% of them are depicted in document annotations. So 30% of them are not. And well, our experiment consists of using a semantic role labeling parser that is the state of the art, in this case Open Sesame, to evaluate the database before augmentation and after the different kinds of augmentations that we are proposing. And we kept all parameters fixed while and default while you're running the experiment for this paper. So we have as I mentioned, those in FrameNet, those frames have different kinds of relationships, and we have evaluate those relationships, and we evaluate the augmentations that we get by exploiting each one of those relationships. And okay, we use standard metrics, and basically here we have the dataset without any annotation. Here we have the dataset with semantic augmentation, lexical, and syntactic augmentations. In the green region right here, we have the percentage of examples that of sentence that have more than 3 examples, and in the orange one is between 1 and 3, and 30% just that there are no examples in the documents. And like using semantic augmentations, we were able to get like 10% of this blue slice of this pie chart. So it's a modest but important result here. We were able to get frames for examples for frames that humans usually forget to write down. And by doing that, like, we just not get more examples, we actually get better performance. We have better precision recall when we use all the relationships. When we use only the strong relationships, and if we only use the use relationship, we don't get much from it. And this is just when we use lexical equivalency. When we use syntactic analysis, we have a lot better results. And when we use semantic representations, it doesn't seem to help a lot. And we believe that it's because the semantic parser used by now wasn't that accurate, and we are still evaluating all the parsers for that. So a few remarks that we might be adding some noise, but for this specific task, even if we are adding noise to the data set, the data set is improving. So and obviously when we are reporting all those metrics on the test data set, and we didn't change the test data set. So when those changes to the training data set are actually helpful for the test data set. And we believe it doesn't matter what semantic role parser we are using, since we use one just to make sure that it made some sense. So another concern is obviously about the overtraining that those methods might cause, since we are making little disturbances to the annotations. Those annotations are actually pretty similar, and it could lead to overtraining. But for this particular scenario, it doesn't seem to be the case, because we had actually better results in the test set. So yeah, it might be imprecise or absent passing result, and this line here is for the semantic parser that I just mentioned. So yeah, we can do some augmentations improving the results in the semantic role labeling. So I think it's a modest but a meaningful result, and this data set is now available, so you can play with those changes as well and see the improvement by yourself. So future work would include other analyzers, other kinds of sentence representation, and other sentence representation methods actually, and try to discover new relationships among frames. Well, besides combining new corpora and resources. So well, that's it. I hope I didn't got too fast and too messy, because I have to say I'm a little nervous. So well, thank you for your